Hello, I am Dr. Nagnath Hulle. In this video, we will try to solve this particular problem. In this case, the circuit shown below, switch is in position 1 for long time. Means switch is in this position number 1 and the steady state was reached. The switch is shifted to the position 2 at t is equal to 0. Means at t is equal to 0, the switch is shifted to this position. And in the second position, we are interested to calculate the 5 values. That is expression for voltage across capacitor, that is Vc of t for t greater than 0. Value of the voltage Vc of t at t is equal to 30 millisecond. Value of the voltage Vc of t at t is equal to tau. The time constant at which voltage across capacitor is 55 volt. And the expression for current flowing through the capacitor and expression for the voltage across resistor. That is, whenever switch is in the position 2, the voltage across this resistance and current flowing through the capacitor, these values we are interested to calculate. Now here in this case, always we have to analyze the circuit in the two parts. One is the circuit before switching, that is t less than 0. I have shown the original circuit here. When the switch was in this position number 1, the circuit will be something like this, because when the steady state is reached, because switch is in the position 1 for the long time, means the steady state was reached, and under the steady state this capacitor acts as open circuit. That's why it is open circuit. So the voltage across capacitor is the same as the applied voltage, which is 100 volt. That's why the Vc of 0 minus is equal to Vc of 0 plus is equal to the 100 volt. That is the voltage across capacitor before switching, that is in the steady state condition. After that, the switch is shifted in the position 2 at t is equal to 0. Means here, whenever at t is equal to 0, whenever the switch is shifted in the position number 2, means we are analyzing the circuit for t greater than 0. The circuit will be something like this, and in this particular case, there is no existence of the source. That's why this circuit is known as a source-free RC series circuit. We will try to solve each point one by one. The first point is the expression for voltage for t greater than 0. Now here expression for voltage for the source free RC series circuit is always given by the expression, that is Vc of t is equal to V into e raised power of minus t by tau, where V is the voltage available across the capacitor before switching, which is the 100 volt. Similarly, we are interested in the calculation of the tau. Tau is the time constant, which is Rc, that is R is the resistance, which is 30 ohm here, and C is the capacitor in this particular case, which is this, that is 2 into 10 to the power of minus 3, which is equal to 60 into 10 to the power of minus 3 second is the time constant. If we are substituting these values, then Vc of t will become Vc of t is V is equal to 100 and e raised power of minus t by tau, and tau is nothing but 60 millisecond. That is this calculation. Then similarly, for the calculation of the second value of the voltage across capacitor at t is equal to 30 millisecond. Already we have calculated this expression. In this expression, if we are substituting this value t as a 30 millisecond, we are able to get the value of the voltage across capacitor at t is equal to 30 millisecond, which is nothing but, if we are finding its value, Vc of t will become 60.65 volt is the voltage across capacitor at t is equal to 30 millisecond. Now third point is the calculation is nothing but the voltage across capacitor, the value of the voltage at t is equal to tau. Means whenever t is equal to tau, we will substitute that value of the t as tau, and tau is nothing but 60 millisecond. That is 60 divided by 60, that is 1 is e raised power of minus 1, and if we are simplifying this value, we will get the voltage across capacitor as a 36.78 volt. That is the value of the voltage available across the capacitor at t is equal to tau. Next here, we are interested in the calculation of the time at which voltage across capacitor is a 55 volt. Now here voltage across capacitor, already we have derived its formula or calculated its values, that is Vc of t is equal to 100 into e raised power of minus t by 60 into 10 to the power of minus 3, that is 60 milliseconds. If we are substituting this value, that is voltage across capacitor as a 55 value, and if we are finding this t, we will get the time at which voltage across capacitor is the 55. Now here in this case we will substitute its value, then we will simplify the simple mathematics is there, then we are taking the log on the both side, that is log of 55, which is equal to e raised power of minus t by tau, that is 60 into 10 to the power of minus 3, and if we are simplifying this, we will get its time, that is t is equal to 35.82 that is into 10 to the power minus 3 second is the time at which voltage across capacitor is the 55. Finally, the last point is the expression for current through the capacitor. Here always the expression for the current flowing through the capacitor is C into dV by dt, that is dVc of t upon dt. Now C is the constant, which is 2 into 10 to the power minus 3, that is 2 millifarad, and d by dt of Vc of, if we are finding the derivative of this function, that is C is the constant, in this particular, this 100 is again constant, this value, then e raised to the power minus t by tau. Now here its derivation is, it is minus 1 upon this 60 into 10 to the power minus 3 into e raised to the power minus t by tau, that is 60 into 10 to the power minus 3. And if we are simplifying this complete expression, then we will get Ic of t is equal to minus 3.33 into e raised to the power minus t by tau is the expression for the current flowing through the capacitor. Finally, the expression for voltage across resistance is given by expression R into I of t, which is equal to R is a 30 and I of t is just, we have calculated this value, minus 3.333 into e raised to the power minus t by tau. And if we are finding this multiplication, then voltage across capacitor is minus 99.99 into e raised to the power minus t by tau, that is 60 into 10 to the power minus 3 is the value. Why this current flowing through the capacitor and the voltage across the resistance is the negative? I will justify this value. Because whenever we are charging up the capacitor takes place, whenever the switch was in the position number 1, in that case direction of the current was something like this. And the capacitor was charged to its maximum value, which is nothing but the 100 volt. Now, whenever switch is shifted in the position number 2, in that particular case, this capacitor acts as a source. In that particular case, the current flowing through the capacitor is in this direction, because this acts as a positive terminal of the battery and this is as a negative terminal of the battery, because this capacitor is acting as a source. Now, this direction of the current is reverse as that of the original direction of the current. That's why this minus sign is there. And due to this, initially polarities was this is the plus and this is minus whenever current was in the clockwise direction. Whenever the switching takes place, the current flowing through the circuit is the reverse. That's why in that particular case the polarities was like this, that is plus and minus, because current is flowing in this reverse direction, that is from the right to left. Now here, these polarities are opposite to that of the actual polarities or polarities when the switch was in the position 1. That's why the voltage across resistance is the minus value. That's all about this video. Thank you for watching this video. Thank you.